See, machine learning algorithms have been classified into three categories. One is supervised learning, second one is unsupervised learning, third one is a reinforcement learning. Okay.
Okay.
Okay. So these are what is the supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning, okay, we'll learn from the past and present to predict the future events. Okay, we learn, we'll have a future data, see last 10 years data, 15 years data. From that data, we try to analyze, and then that is presently what is the data, current year data. Then we try to predict what is going to be happen in 2021 and all. This is what the supervised, something that is here. Analysis of known training data set. The learning algorithm produces an inferred function to make predictions about the output value. Okay. See, last 10 years data, 5 years data, I try to predict what is the today's what to say weather report, and what was today's weather, it will going to be rain or not, what is the traffic in the Bangalore, or now we have series of in India we have festivals are coming, like for that is Deepavali and all, or say in general, say yeah, in December we'll have what to say Christmas is there. Fine, how, what is which that is which product, which item has sold more in say Christmas, that I want, so that I will have, I will have, make a more production of those products, in which country, in which area people will like what. So these are the analysis I need to do. So for that we'll go through the last 4-5 years data, and then we try to predict, or we try to analyze that yeah, in this coming Christmas which product we have to make a more productions. That is what supervised learning is. Here now, say for example you are learning Python, I am guiding you, or I am insisting you, just I am giving you, providing some kind of brush up, that is Python. This is called it as a supervised learning, right?
Yeah.
Okay. You are trying to learning from me, that is me, I am trying to giving you some inputs, I am giving some guidance, how to do Python, what is the Python, how and all. This is what called it as a supervised learning. When you coming into the supervised learning, here, yeah, supervised learning is there. Then the supervised learning is categorized into two. That is, it is again categorized into two. One is classification, another one is regression. Now we will go with the regression. After this PPT, I will go with the regression. See, that is the prediction. Classification problem is when a target variable is categorical. Guys, what do you mean by categorical? Do you know, do you have an idea about the categorical variables?
Yeah, it's classified into several groups or something, or classes. Correct.
See, classic categorized categorical variable, in the sense I will say result. Say you are well versed with the stock market, right? The stock market is grouped into what? Yeah, it is today the stock market, that is the Sensex is up or down. Okay, that is up is a one category, well classified into up or down. Some of the script are up by some percent, right? Say 2%, 5%. Are we categorized? Are we classified? Metal, and then IT sector, right? And our chemical. Like this, we do classification. Chemical, how much it has been gained. IT sector, how much it has been gained. What to say, from automobile, how much it has been lost. This is what categorized, right? Gender wise, say female, male, this is what a categorized. Or say maternity status, say you are a, what to say, you are a married, unmarried, diverse, single. This all called it as a categorical variables. Classification algorithms, I mean classification we done for the categorical variables. Getting a guys?
Yeah.
The value is low, high, medium, or else you people are making, I mean, we are in a social media or in a, what to say, e-commerce site, the any product will make it into, say, our movie, you will go to, say, categorize good movie, average, excellent, you will give the feedback review, right?
Yeah.
Those are all called it as a categorical output to be classified into classes. Okay, either it belongs to class A or class B. The classification problem is when the output variable is category, as I told you. Say for example, color, it belongs to red color, blue color, disease, no disease. With respect to email, the email what you got, it is a spam or a not spam. These are all called it as a classification. So supervised learning, we have two categories. One is classification, another one is a regression. Regression, we try to go for the prediction purpose, right?
Yeah.
Yeah. Yeah. So see, here this is what I have at a boundary, decision boundary. So the decision boundary is making a classification of my red color and a blue color data. That is, data has been classified into C. Fine, this is what randomly I have. Then I'll take a one boundary line, decision boundary line. The decision boundary line making the classification of my bifurcation of my red color and a blue color data. This is the one example. Some of the most common algorithms we are using: K nearest neighbor, naive Bayes, decision tree, random forest, support vector machine, logistic regression. These are all some of the very popular, most commonly used algorithms in our machine learning. Okay. Yeah, please. This is what we have classification. For example, let me go with regression. Guys, any idea about the regression? What is this regression? It's a method, right? It is a statistical method where we are using in finance, investing, and other disciplines that attempt to determine the strength and character of the relationship between one independent variable, and you may have a one dependent variable is there, but you may have one independent or more than one independent variables is there, right? What is the regression?
Yeah.
It's a statistical method where you are applying finance. Say, just now I told you what will going to be happen for my stock market, what is happening into the loan, that is whether credit card fraud. Nowadays we have a credit card fraud. What will happen? Whether the person entering into the bank, whether he is eligible for accessing that credit card or not, whether you have to provide a credit card or not. These are the predictions that I make. So it is relationship between what? One dependent variable, okay? Usually mathematically we will denote it by a y, and a series of other variables. There are all other variables, they are all called it as an independent variable. Very general, what to say, this is the regression. So, guys, you have idea, right?
Yeah.
Yes, good.
Yeah.
Yeah. Now, what happens? Regression problem is when a prediction must be made. When I make a prediction, then and the target variable is a continuous, that is the output is a numerical value, right? When you have a numerical values, then we will go with a linear regression or multilinear regressions. When you have a dependent variable is logistic, yes or no, true or false, 0 or 1, then we'll go with a logistic regression, right guys?
Yeah.
Yep.
Yeah, these are the some common widely used algorithms are linear regression, logistic regression. Statisticians, you people will call it logic, correct? Then and the third one is a decision tree, random forest, Gaussian progress regressions. These are all so many regressions are there. Okay, see here, this is the one example again I've taken. It is you will have a best fit line with the points which are having data which is fitting nearer to that line. That is what some example I had taken. Let me coming into the second one is unsupervised learning. In the unsupervised learning, basically this unsupervised learning you are heavily used in AI system. AI system stands for artificial intelligence. Okay, we have some we'll make the system to learn by itself. That is here. In unsupervised learning, an AI system is presented with unlabeled, uncategorized data, and the system's algorithm act on these data without prior training. We are not given any training. Okay, the output is dependent upon the coded algorithm. Yeah, behind the screen, we are running so many algorithms. Subjecting a system, okay, to unsupervised learning is one way of testing my AI. So the unsupervised learning is categorized into two other. One is clustering and another one is association. Okay, guys, we are
Yeah.
grouping. That grouping is called it as a clustering. Association, you three are the participant, right? You are associated with each other. Am I right?
Yeah.
You three participants are there. All these three participants are you are associated, right? And clustering, in the sense, what happens? It is something that is again, it is a grouping, but based on the some common characteristics. Okay, I try to make a character, that is, I'm making a clustering based on the common attributes, common characteristics. That is what a clustering, right?
Yeah. Yeah.
Yeah.
That is what, yeah. Any doubts, please, if ask me, and we'll have some discussion, because you have, what to say, commerce background, economic is there, then you know statistics. Fine.
Yes. Yes.
Yeah, please. Now, this is what the unsupervised learning. Clustering, again, a set of input is divided into groups. Unlike classification, the groups are not known. We don't know, because in the clustering, we don't know how many groups is required and all. Just we'll keep on making. I will make a group based on the type of input that we are providing. Okay. The groups are not known beforehand, making this typically an unsupervised talk. So what are those methods? Clustering, we are using a Gaussian mixture. K means clustering, hierarchical clustering, okay, spectral clustering. There are different algorithms are there. Okay, see, this is the original cluster. Earlier it was blue, then after the cluster, that is unclustered data, then the second part is the clustered data. This is what we have, a sum of the data, blue, red and green color are there, right? This is the clustering operation. Earlier, we don't know how the data is. As on reading the data, we'll come to know that there are three different colors of data are available. Okay.
Yeah.
Reinforcement is combination of what? Both supervised and unsupervised. This is learning method. Interact with the environment, producing actions and discovers error or rewards. This is trial and error search deployed towards the most relevant characteristics. This is the combination of both of this one. Now we'll study about the regression. There are basically most commonly used regression algorithms are linear regression and logistic regression. You guys will call it as a logit. Am I right? Okay. Now we'll study one by one. What is this linear regression? As you are aware, this algorithm is based on supervised learning, and it performs the task of regression. Regression model a target prediction value based on the independent variable. Linear regression performs the task of predicting dependent variable y based on the given independent variable x, or you may have a more than one. Obviously, we have a more than one independent variable. So this regression techniques find out a linear relationship among or between x and y. Am I right, guys?
Yeah.
Yeah.
Yeah. That is a different regression models differ based on the kind of relationship between the dependent and independent variable they may considering, and the number of independent variables are being. Say sometimes we have over, that is a kind of input variable, that is independent variable that it is consisting of. Okay. As I told you, your dependent variable is 0 or 1, yes or no, true or false, then we'll go with the logistic regression, right? Yeah, the basic formula that what we have studied in since from the what to say in school days or in mathematics, this is the what formula. Y cap, that is y is equal to b naught plus b1x plus e, or a b usually will called. B naught is what? Intercepting. B naught and b1 is call it as what? Coefficients. X is what? Input variable, or we'll call it as a independent. E is the error. What is this error? E is what? The difference between the prediction and actual value. Correct?
Yeah.
Yeah. Yeah.
Correct? The error term is what? What I have predicted, but what is exact? What actually it is that the difference is called it as a error. The success of any model, or the accuracy of any model, or what is the accuracy of the prediction, what we are going to predicting, say that is the traffic in the Bangalore, or traffic in your Jakarta, or whether today will going to be raining or not. Everything is that accuracy depends upon my error term. As the error is less versus my accuracy will going to be get increases. Correct?
Yeah.
Right? Yeah, this is again the second one is when you have a more than one independent variable, that is the equation goes. See, this is a very simple one you have. B, that is line you are going to, B naught is intercepting my, when X is, B naught is, my X is 0, where the Y value will going to be get in. This is the model, I mean very basic thing I have taken. These are the types of regression model. Positive relation, there is no relation, I mean negative relation, okay, relationship is not linear, no, there is no relationship. This is what happens between the data. Yeah, guys, here what is my, I have one diagram. See, this blue line dots are my input data, right? When you draw this that is B naught, that is my best fit line, how the data is have been scattered with respect to my best fit line. This red color line is called it as a best fit line. Okay, some of the data are on the line, some of the data are above this best line, some of them are below. This difference is my UI. Correct, guys? That is error term with respect to my X. Am I right?
Yeah.
Hmm?
Yes. Yes.
So we are going for the squaring. That is sum of square errors we are going. Am I right?
Yeah.
Yeah.
See, the functions again, it is I think it is Y is independent, population Y intercept, B naught coefficient B naught, X is independent, random term, statistically U is called it as a random term error, or we'll call it as a residuals. This beta naught to B1 X called it as what? Linear component. U is called it as a random error. Somebody will use the notation E also. Okay. This is what action.
Yeah.
So this is
Yeah.
what I have. EI is the difference between the predicted and the observed value and the predicted value. That called it as a EI. This is the random error for this X value. The slope versus that is beta naught is going with the best line to the predicted line. This is what a pictorial representation I have taken. Yeah, this is what. Yeah, guys, what is this hypothesis? Hypothesis test. Do you have idea about this hypothesis? 1 minute. I'll go back. Yes, null hypothesis, alternate hypothesis. Hypothesis is what? Assumptions, right?
Yeah.
Yeah, kind
Yeah,
assumptions, right? We are assuming that suppose my coefficient is 0. See, here beta naught is 0. That is linear relation. When my beta 1 is 0 or 1, coefficient B1, beta 1, and we are checking, right? When beta 1 is 0, there is no relationship. Obviously, my independent variable will become 0. So there will be no relationship. Correct? That is what null hypothesis. Am I right, guys? I hope you understand. I can't go in detail because again, that itself will take a lot of time. Am I right? Simply I'm briefing. Hypothesis is with respect to the coefficient. Say I have a coefficient beta naught is my intercept, that is not here. Beta 1, beta 2, beta 3. Whether coefficient value is 0 or not, that I have to check. Correct? If coefficient are 0, then there is no meaning in that for that independent variable. Am I right? So before getting into that, we are checking the coefficients value. That is what hypothesis say. Here you have a null hypothesis and an alternate hypothesis. When beta naught is equal to 0, so there is no really linear relationship among my dependent and independent. When beta naught is not equal to 0, obviously there is a relationship that we have to check whether we have a positive relationship or a negative relationship. That is okay. The test is, this is what we are performing, b1 minus beta naught divided by s, that is a estimated error and all. These are some standard formula. Guys, in Python, what happens, no need to break your head or no need to, just you can use directly the function called it as a LM, linear model. The linear model function will take care all these things. Just for understanding purpose, we are using, I'm just included in my PPT what exactly, okay? Inference is fine. I hope you are understanding. Yeah. Any doubts here? Please, guys, just ask me so that I'll go ahead with this. Shall I go ahead?
Yeah.
Let's go ahead.
Yeah. Please see here, more mathematical way I had taken. What is this y cap? That is your green color line is my mean. Is it my y dash? This is a green color line. You can see my this is.
Yeah.
This is the mean of my data. Blue color line is y cap is my what is this, my predictor value? See what is this
Yes.
Yeah, what is this SST? That is a total sum of square. Why I am doing sum of square? Because some of the data is lying above the line, some of the data is lying below my best fit line, that is a y cap. Am I right?
Yeah.
Yes.
Yeah, so to avoid the negative value, what I'll do, sum of the square, so everything will become a positive value. That is what SST stands for, total sum of square errors. Guys, please, here you try to understand basic concept behind this explained and unexplained variation, right? SSE stands for sum of square errors. That is here. Difference, that is sum of yi minus y cap square. RSS stands for what? Regression sum of square. Yi cap minus y dash, that is y dash is what? Mean of my data. Am I right?
Yep.
Now, from the mean,
yes.
yeah, the difference between mean to the best fit line, from the best fit line, the difference between the predicted and actual, that difference is we are going to calculate it, right?
Yeah.
Yep.
Okay. Please, guys, am I right?
Yes.
Yeah.
Correct, na? This, I think this your this is more in a diagram is, I think, SSE, then SST and RSS, that is the regression sum of squares, sum of square error, SSE. That SSE is supposed to be a less so that I can achieve my accuracy. See, SST is what? Total sum of, measure the variation of yi values around their means. SSE is what? Sum of square error, variation attribute to the facts that other than relationship between the x and y. Why I had to find out now why, when the, what is the relationship that is existing between what? Dependent and independent variable, and correlation among the set of independent variables, right?
That's right.
There is a relationship between what? First I'll find whether there is a relationship between a y and x. When x is increasing, correspondingly y is also increasing. Yes, then there is a positive relationship, right, guys?
Yes.
Yeah.
Okay, yeah. And I have a set of independent variables, say x1, x2, x3. When x, I am considering in my model x1, x2, x3, whether there is a correlation between x1, x2 or x2, x3. That also I have to find out, right? Yeah. Correlation. SSR is what? Regression sum of square. That is, it explained variation. Okay, this is the explained variation that is attributable to the real that is a relationship between my x and y. Correct, na? This is what some term we are, of course guys, here you just this is for all these things is for explanation purpose, to understanding purpose what exactly the regression will do. See here, SST, that is total sum of squares, is sum of square error plus RSS. Correct guys? SST is total. What is this SST? Summation of y minus y square, that is y, sum of error is what? Y minus y cap error. SSC is y cap minus y. This is the y dash is what? Average value of the dependent variable. Y is what? Observed value of the dependent variable. Y cap is what? That is my estimated value of y for the given x value. Correct?
Yeah.
Yeah, go through this. Just is there any, this is what explained and unexplained variation among my data set are in my equation. Okay. Yes, guys. Yeah. Shall I go ahead?
Yeah.
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 I think you have heard about R square, adjusted R square, right? Our error term, that is, okay, R square, adjusted R square, we'll call it as R square. That is, what is this word? The coefficient of determination is the portion of the total variation in the independent variable that is explained by the variation in the independent variable, right? The coefficient of determination is also called it as what? R square, and it is denoted by R square. What is this R square? SSR divided by SST. Always my R square value is lying between zeros and 1. Okay.
Yeah.
Yeah.
See, sum of square explained by the regression, total sum of the square. Here, what is this? R square is equal to R is the simple correlation coefficient. This is the one. R square is SSR divided by SST, where R square is equal to small r square. Okay, coefficient of determination. R is what? Simple correlation coefficients among the my data set. Okay. Is it okay, guys? See, simple. R square is what is the value of R square? R square is equal to 1, plus 1, minus 1, less than 1. This is how the relationship is got. When R square is equal to 0, there is no relationship among the values. Okay, see here. Less than 1, positive relationship, and a negative, weaker relationship between x and y. That is what just now I told you. Okay. Plus 1, minus 1. These are the some kind of. Yeah. Logistic regression, say you are going to using the independent variable is a yes or no, or 0 or 1, true or false, then we'll go for this one. When you are going to see, logistic regression is a supervised classification algorithm. It is a classification also, because we are going to making a group of ones and a zeros and a ones. In the classification, target variable can only be a discrete value for a given set of my x. Is a regression model. Logistic is a model which can be used for both regression and also for the classification. Logistic regression model does not make use of normal probability, but rather it uses the, see, we are using the log of odds and iterative maximum likelihood method rather than least square to fit the final model, right? We are using the probability theory, that is log of odds and what to say, maximum likelihood method we are applying in the logistic regression. Guys, no need to break it, how we have to calculate log of odds, maximum likelihood and all. Everything, if you use a GLM function in your Python, automatically it will take care of all those things. Just for understanding purpose, how backside, how it runs, these are the some concepts we are included. Is it my simple logic with respect to statistic? Logic of P. P is a prediction. Not prediction. Probability is B naught plus B1x, guys. Okay. Guys, please look at this formula. Logic of P. What is this P? P is a probability. Am I right?
Yeah.
Yeah, that is log odds of logic is assumed to be linearly related to whom? Independent variable x, correct? log odds, that is a logit, is assumed to be linearly related to the whom independent variable x. So we can have this linear. See, this is my probability formula, guys. Ln, that is a log p divided by 1 minus p, that is probability minus 1 divided by p. This is the what to say formula derivations that we are going to using in logistic regression. Am I right? So converting p divided, then e to the power, then p again. These are the some derivations I had just for rebrushing your this one, which gives p is what sigmoid function. Okay, this we are using, called it as a sigmoid function, and we have a sigmoid curve, that is a S curve instead of this one. When a response variable is binary, the shape of the response function is often as a sigmoidal. In a linear we have a straight line, but in logistic we have a sigmoidal wave. Correct, guys? Now data is moving between 0 and 1. Okay, my y is having the value between a 0 and 1. Am I right?
Yeah.
Yeah, this is the same. How we are going to interpretation of beta naught, that is my coefficient with respect to logistic, odds of 2 divided by odds of 1. Calculation x divided. These are the some calculations I had taken, guys. Sure, I think you can understand this one. Okay. Here the calculation with respect to coefficient for logistic regression is, this is odds of 2 divided by odds of 1, e to the power of something, e to the power of beta. This is what we are performing in statistically, but here in Python we are not writing all these formulas, we are not going to deriving anything directly, we are using the functions. Okay, see some of the examples I have taken. I will skip all these things because it is not required. Okay, hypothetical function. This is classification. I will come back, guys. Once I'll start the classification algorithm, I'll come back with this classification. Okay, I will we'll go for coding with respect to linear regression and followed by a logistic regression. Okay, I'll come back again for this PPT for when I start doing the k means and a knn.